lesson here for Chapter 7. It'll be a quickie. But before we start that, were there any questions from the previous homeworks, Landon?
You're number 8.
Number 8? Sure. So we'd start by adding 4 to both sides. And then dividing both sides by -2. And then we'll use the exponent base of 1/2 to cancel the logarithm. And 1/2 squared is just 1/4. Like that's something you could type in your calculator if you weren't sure. And you just subtract the 2 over. It's like -1.75. And that checks out. Since when I plug that in for x, I still get a positive number. That's it. Don't let the fraction get you all squirrely on it. It's no big deal, right?
I'm still kind of confused on what I get it. I understand like why the I don't know. I'm so confused why the log half just takes out the 2. Like I don't know.
The log half didn't take out a 2.
Like didn't it cancel the 2 out with the other stuff?
No, the 2 became the exponent.
So you just push the 2 up and then the half becomes the main.
So what you have, doing this to both sides, is that's still equal, right? If you had 2 things that were equal, and you take equal exponents and you put them onto equal bases, you still have an equal equation, right?
Yep.
This cancels,
Which is on the other side.
which is the x plus 2, and then the 1/2 squared is 1/4.
Okay. Alright. Yeah.
Is that okay?
Yeah, I just didn't.
Yeah, it's okay. Gabby, did you have a hand up earlier?
It was the same one.
It was the same one. That was helpful. Enzo, 3. Okay. So this one, the exponent bases are different, and there's really no way to write them so that they have a same base. Well, I mean, there's no convenient way to do that. So what I would do is I would either take the natural log of both sides to cancel the e, or I would take the common log to both sides to cancel the 10. It doesn't really matter. Either is fine. For the sake of argument, I'm going to do the natural log. Because it's one less letter to write, basically, is my justification there. So far, so good. I'm going to then use the power property, which allows me to take that exponent and move it to a coefficient. And then the natural log of 10 is just a decimal, right? That's just a number. So for instance, the natural log of 10 is about 2.303. So I can just distribute that through to the 2 and the -3. Do the same thing. 698. So I can do that. It's okay with that, Enzo? And then I can just like subtract 3x from both sides. That turns it into like 1.605x. And I can add 6.908, which becomes like 7.908. And And then if I divide by the 1.605, I'm done. Oops. Missed the 6 there. So that's about 49.27. Is that okay? And again, the logarithm that you used in the beginning, you could have used the common log also, and you would end up with the same answer. The steps in between become a little different because you did use a different logarithm, but it's still kind of the same procedure. You're just canceling the 10 instead of the e. Anybody else? Okie dokie. Well, we can always circle back later if you guys come up with more stuff. That's fine. Today, we'll worry about the last lesson for Chapter 7. So we're going to be talking about graphing logarithmic functions. So the general form for a logarithmic function is y equals a times log base b of x minus h. And what just happened, one note, it's on me. Yeah.
I thought it stopped freezing.
Thought what?
I thought one note it stopped freezing.
It seemed like it was working good last time, and then this is like the first time in a minute that it's been being a poop butt. So that's our general form equation. There is one key feature that we have to make sure that we include. That is, every logarithmic function has a vertical asymptote at x equals h. No big deal there. Relatively easy to identify. And the way we're going to make our xy table is as follows. We're going to do it this way so we don't get all irrational values to graph. So the way we're going to pick our x coordinates is as follows. B to the negative 2 plus h, b to the negative 1 plus h, b to the 0 plus h, b to the 1 plus h, b to the 2 plus h. And then our y coordinates then are going to be negative 2a plus k, negative 1a plus k. I'll put the 0a plus k just to kind of keep the pattern going. 1a plus k. 2a plus k. Notice the exponent on the b is going to be the same as the coefficient on the a. Okay. And then the last little piece of detail we need to talk about is the domain range. And then we can do some examples. domain and range is easy to deal with. The domain is going to be always h to positive infinity, and the range is going to be negative infinity to positive infinity, or also known as all real numbers. Okay, let's do a couple of examples. We'll run through the details here and kind of apply what we just went over, and then we'll be done with this lesson. Should be a quickie.
This is our last lesson.
Last lesson for chapter 7. That is correct. So let's say we wanted to graph y equals 3 times log base 2 of x plus 1 plus 4. So here my values for a is 3, b is 2, h is negative 1, and k is 4. Again, remember the h is always the opposite sign of whatever it appears in the formula. Or the equation, I guess I should say, not really formula. And we know that our vertical asymptote is going to be x equals h. So that's just x equals negative 1 in this case. And then we'll make our xy table. So I'll do b to the negative 2 plus k, b to the negative 1 plus k, b to the 0 plus k, b to the first plus k, and b to the second plus k. We'll do negative 2 times, oh my goodness gracious here. Sorry. We're supposed to be adding h. And adding negative 1 is the same as subtracting negative 1, so just skip the plus symbol. Sorry about that, guys. Sorry about that. And the y-coordinates, negative 2 times a plus k, negative 1 times a plus k, 0 times a plus k, 1 times a plus k, and then 2 times a plus k. So when I simplify this, I get negative 0.75, negative 0.5, 0, 1, and then 3. It's going to be negative 2, positive 1, 4, 7, and 10. Again, you could type those things into your calculator to evaluate them. I just did it in my head. You know, whatever you're comfortable with is fine. But that's the way I kind of like to set up my tables. I write the little expression in there, and then I'll simplify it afterwards. I tend to make less mistakes that way, or if I am making a mistake, like I started doing the plus k's instead of plus h, it's easier for me to catch it and go, oh, good. If I just had the numbers there, I'd be sitting there graphing something that doesn't make any sense and be going, why the heck doesn't this make any sense, and not being able to figure it out. Anyways, let's draw our graph then. Negative 1, 2, 3. 2. I'll draw my vertical asymptote. And then we'll start graphing. So, yeah.
Alright, should I go fill this up?
Sure. I have negative 0.75 and negative 2. So down here. Negative a half and 1. 0 and 4. 1 and 7. And then 3 and 10. Draw my graph then. Sorry, got a little shaky there. So again, that should be curved, right? Shouldn't be a straight line. Shouldn't be passing through the asymptote, right? The asymptote should be bounding it. And then needs to have arrows at both ends. And then the last thing we do is need to write our domain and range. The domain is h, which was negative 1 to positive infinity. And the range is negative infinity to positive infinity. So just do, what do you say, like one more example, make sure we got it, get out of town here. Sound good to you guys? But again, relatively easy concept. We probably could have squeezed this in somewhere else, but why? Right? Why? We're doing good with where we got to this year, so I did no need to rush. Okay. So let's say we want to do negative 3 times log base 1/2 of x plus 4 minus 5. So here my a is negative 3, my b is 1/2, my h is negative 4, and my k is negative 5. Again, remember the h is always the opposite sign of what it looks like in the equation. So my vertical asymptote then is x equals negative 4. And then we'll build our xy table. So I'll have b to the negative 2 plus h, b to the negative 1 plus h, b to the 0 plus h, b to the first plus h, and b to the second plus h. That's negative 2 times a plus k, negative 1 times a plus k, 0 times a plus k, 1 times a plus k, and then 2 times a plus k. To simplify this, let's see, we got 0, negative 2, negative 3, negative 3.5, and then negative 3.75. I got 1. Oops. Sorry about this, guys. That 3, somehow that negative 3 got wrote down as positive 3 after the first one. Make sure I got that in there. And that should be negative 2. Should be negative 5, negative 8, and negative 11. So then we just need to kind of plot our points, draw our graph, and then do the domain and range part. Yes, sir.
Really quickly, why is the 4 negative?
Why is the 4 negative again?
Yeah, in the equation it's positive.
The h is always the opposite.
Oh, that's right.
Right? Because it's in the general form. It's a minus in the general form.
And the VA is always
So if it's
the
a
same.
plus sign, it's like always the opposite. Yeah, no problem. One, two, three, four. asymptote here. And then let's start plotting. I'm going to start at the far end of my table to plot because I like to usually plot things from left to right. So the negative things are at the end of my table here just coincidentally. So negative 3.75 and negative 11 is like here. And then negative 3.5 and negative 8 is like there. And then I have negative 3 and negative 5 is like there. And I have negative 2 and negative 2. It's like there. And then 0 and 1 is like there. And a little longer. Draw, connect. My arrows at both ends. And the last thing, the domain and range. The domain is always h to positive infinity, and the range is always all real numbers.
That's pretty easy.
Yeah, not so bad, right? So you have to remember the table or whatever, but that's not even that bad. Pretty doable. So your assignment for this lesson, I just have 3 graphing problems for you to do. So same kind of directions that we did in the example. Identify the A, B, H, and K. Write down the vertical asymptote. Make your XY table, plot your points, draw your graph, and then do the domain and range. I've also put on the content library, the test review. So I have the test review set up here. When you're done with the homeworks, you could certainly start the test review. I've included the review key with that so that you can kind of check things as you go. So the plan for next week, let's see, this is Thursday. So Monday we'll take a day for a review to just kind of answer general questions or whatnots. And then Wednesday would be the test day for Chapter 7. And then next week it's a 3-day week. So we have a day off for graduation and Memorial Weekend.
Thursday, Friday.
Monday and Friday are off.
Next Monday, next Friday.
No, not next Monday, next Friday.
Next Friday, next after next
A week from, 2 weeks from Friday, and a week from Monday.
Monday.
Anyways, so that 3-day week, this class meets on Wednesday. We'll do if you wanted to opt to do the retake, a chapter test retake instead of taking the double high test score, we'll do that on that day. You do need to notify me in advance of that, so if that's something that you're considering, make sure you send an email and let me know if that's what you want to do. You can certainly wait till you've taken Chapter 7 test. There's no reason to rush on that too badly, but I need to know by the end of next week if that's what you want to do. Otherwise, I'm just going to give you the double high test score, and that's fine. No big deal. And then after that, I think we have I think we might have 2 days the following week and then exam start or something.
Is there still no word about the exam?
They're meeting today to talk about it, so I don't have any result on that yet, but I'll be able to let you know probably next week on what the dealio is. Okay.
Okay, thank you.
Yeah.
Oh, also, is it always going to be -2, -1? answer of it too, like for the graph.
The exponents?
Yeah.
Yes. Yes. So the exponents, when you're making your table, will always do that. You're asking about these guys, right?
Yep.
Those are, we'll always use those ones. That'll give us a good picture, or should give us a good picture every time. And that's it here, folks. So I'm gonna stop the lesson.